Hey physics! So today we're going to work on practicing being able to recognize the six forces that we talked about last time and being able to identify them and also make a system schema about them. With this one, you don't actually have to draw the system schema, you just have to label the parts in it. So what I'm going to do is I'm going to talk you through, we'll review the forces, the six forces again. I'm going to go through problems 1 and 2. And then in this asynchronous time in the morning, I want you to go through 3 to 5 on your own. And then we'll go through like 6 through 8 in class. And then I'm going to have you do 9 through 11 on your own. Just kind of like I do, we do, you do, to make sure you know how to do this. So recognizing forces. I've got this picture of a bike here because you can think about like how many forces are involved in when you're riding a bike and what all those might be. So this is all kind of stemming from Newton's first law. Newton, remember, is the guy who sat under an apple tree and the apple fell on his head and he was like, oh, gravity and forces and all of this stuff. He kind of thought about this whole, it's kind of like the grandfather of physics, I suppose you could say, in some of the forces anyway. So an object at rest will remain at rest unless it is acted upon by an outside force, right? If there is a rock there, it's going to just hang out unless something moves it. Whereas an object in motion is going to continue its motion in a straight line unless it's acted on by an outside force, right? So basically, like, everything kind of keeps doing what it's doing unless it has reason to do something different, right? And yeah. So like, for example, if I throw a ball in the air, like, it's going to go straight except for that gravity's acting on it, so it's going to come down. But if I was like in outer space, right, if a thing starts going in one direction, it's going to keep going in that direction unless something else acts on it. So these are the forces. We have the applied force, which is a push or pull that is applied by a person or other object. So for example, this skeleton is pushing over the Leaning Tower of Pisa, and that's the applied force there. And this girl is kicking the soccer ball, so they are both applying forces to an object. We have the force of gravity, which is the force that pulls an object toward the center of an extremely large object, like a planet or a star. Gravitational force. And that is a non-contact force. It's an action at a distance force, because if you think about it, if you jump up in the air, you're not touching anything, but gravity is still acting on you, right? It's pulling you back down. We have the normal force. I'm going to make this a bit smaller so you can actually see the whole thing all at once. We have the normal force, which is the support force that holds something that is in contact with a stable object or surface. So that can be like if you have a table and something resting on the table, the support of that table for that object is the normal force. But also, I'm leaning against a wall right now, so the wall is also supporting me with a normal force. That whatever is that stable object is supporting the thing. So that is normal force. We have air resistance, which is a frictional force that acts upon objects as they travel through the air. So you can think about that like when you are in a car and it's going down the road and you've got your hand out of the window, that air pushing against your hand is air resistance. That same kind of thing happens with like a feather falling, and it also happens with an airplane. I mean, anything that's going through the air has that air resistance pushing against it in the opposite direction that it's moving. So then we have the spring force, which is it's a bidimensional, I don't know if that's the right word, but it pushes in both directions. It pushes up against you and it pushes down against you. If you're trying to squish it, it's pushing back up and down. If you're pulling it open, it's pulling you back. It wants to be a certain place. So spring force acts on both sides of that object. Tension force also is another one that works on both sides. So for example, if you are walking your dog, when that leash is tight, then the dog is feeling that tension and you are also feeling that tension. You can think about that like if you're going fishing too, right? When that fish is on the line, the fish is feeling the tension of the fishing line and you're also feeling the tension of the fishing line. Okay, so now we're going to do some examples here just to practice that you can recognize these forces and can identify them in action. So A block hangs at rest from the ceiling by a piece of rope. Okay, so is gravity a force that is going to be there? Yeah. Is a spring force there? No, because we don't have a spring. But is tension there? Yeah, because we have this rope that is tight, and so it's going to be pulling on the ceiling, and it's also pulling on the block. Normal force, it is not being supported by anything. It's not like directly leaning on the ceiling or the floor or anything like that, so no. Friction, there is no friction going on. It's not rubbing against anything. I don't know if I put friction up there, actually. I totally forgot friction. Anyways, you know about friction. And there is no applied force going on. Okay, so that's the thing there. So now let's look at a system schema. So the object of my focus is going to be in a dotted line. So the block is the thing that is hanging at rest from the ceiling by a piece of rope. So I see that there's a dotted line here between the block and something, and so that means that it's a non-contact force. So I happen to see that I have tension on both sides here and gravity as the other one. So I happen to know that this one's going to be gravity because it's that dotted line which signifies a non-contact force or an action at a distance force, which means that this is going to be Earth. Earth is always going to be one of the bubbles here because that's what gives us the force of gravity. And then I see that I have tension here. Tension is the force that happens with ropes or with strings, cables, anything like that when they are taut. Or tight is another way to say that. Okay, so block, rope, and ceiling. Okay, so that's that one. Here's the next one. A block hangs from the ceiling by a spring. So is gravity a thing here? Yeah. Is spring force a thing here? Yeah. Is tension a thing here? No, because it's that spring force. It's not, nothing is tight here. There is no normal force. It's not being supported by anything. It's just hanging from that spring. There is no friction here, and there is no applied force there. So just gravity and the spring force. So this one looks a lot like the one before. So we have this dotted line signifying that the block is the object of my focus. I have a dashed line here between the block and the earth, because the earth is pulling down on the block with the force of gravity. And I have the spring here holding the block to the ceiling. So that spring force is being held or being felt between the block and the ceiling. Okay? So that kind of gives you some background there on these. So now I want you to do numbers 3 through 5 and then stop there. We'll come and check these and then we'll do the rest during synchronous time. Okay?